All right, guys, I hear a lot of people are struggling with these graphs, so I'm going to kind of show you a little bit of how to do this. This is a rough drawing of problem number 1 from the assignment. So the amplitude is going to be halfway in between this vertex and this vertex, meaning that the distance between these two, height-wise, divided by 2. So I'm looking at this one, it's at 1. I'm looking at this one, it's at, oh, I should be minus, minus -5. So 1 minus -5 divided by 2, which is going to be 6 divided by 2, which means I have an amplitude of 3. So to find the amplitude, I'm going to take this minus this and divide by 2. If you remember on the original either sine or cosine graph, we had an amplitude of 1 because this went up 1 and this went down 1. So we looked at, I'm off the graph, we looked at the midpoint there, which would be 1 minus -1 divided by 2, which would be 2 over 2 or 1. Our, this is a sine graph, so our cosecant is just the 1 over that, so it flips it over, right? So your amplitude is still going to come from what is this height divided by 2, all right? So that's how I'm going to find the amplitude on this guy. Now, I'm going to look at where it starts to decide if I want to make it a cosecant or a secant graph. I'm looking at this being pretty close to the cosecant because just the way it looks like it's shifted like a cosecant as opposed to a secant. So I'm gonna say that it's a cosecant. Now, technically speaking, you could write either one, but I'm gonna do it as a cosecant. So my cosecant, if you remember our original like sine graph or original cosecant graph, were measured in pi's over 6. And on our sine graph, we go like this. So on our cosecant graph, we go like this. Meaning that my vertex is right here at pi over 2. On this one, my vertex is not at pi over 2 because this is pi over 2, right? It's actually shifted over to the left halfway. So if it's shifted over halfway from here to here, that's a pi over 4. So since it moved to the left pi over 4, that tells me that inside of my parentheses, I'm going to have theta plus pi over 4. Already said I'm going to make it a cosecant, and I already said that the amplitude is 3. Now, to find my up-down shift, what I'm going to do is I'm going to find the midpoint in between these two. What is halfway there? On the original graph, on the parent function, the halfway point is 0. I went up 1 and I went down 1. So on this one, I'm trying to find what's the halfway point. The halfway point in between 1 and -5 is 1 plus -5 divided by 2, which is -4 divided by 2, which is -2. So if my halfway point is now -2, that means that I subtracted 2 from the function. So that's how I come up with the function of f of theta equals 3 cosecant theta plus pi over 4 minus 2. Okay? I'm not going to draw the other graphs, but if you could look at them while I do it, I am going to explain them out. So on number 2, I'm looking at a distance from 5 to -1 for my amplitude. So 5 minus -1 over 2 is going to be 6 over 2, which is going to be an amplitude of 3. I'm looking at it, and this one looks like a secant because it's starting down instead of up, meaning my cosine graph goes like this, which means my inverse of that is going to be like here. And I feel like what I would do is I would just shift this to the left, or sorry, shift this to the left. So that's what I'm thinking is happening, is that I shifted this to the left because it starts down. So let's see, what do I got? I got a shift of, this should be at pi, and it's now at pi over 4. So to move from pi to pi over 4, I'm gonna have a to the left of 3 pi over 4. So I said that I want to do a secant. I said that I have an amplitude of 3. I said I'm going to shift to the left 3 pi over 4. And then I'm going to find the halfway point. So the halfway point in between 5 and -1 is 4 divided by 2, which is 2. So I'm going to add 2 to that.